if c is not equal to 0, evaluate the following integral. So the integral is integrate from 0 to infinity, exponent to ct with respect to t. So this is an improper integral. So what we need to do is just introduce a limit. So we say that the integral from 0 to infinity of e to ct with respect to t is the same as the limit as n tends to infinity of the integral from 0 to n of e to ct with respect to t. So we are just going to integrate that from 0 to n. So we have the limit as n tends to infinity, then we integrate this function. So we're going to have 1 over c e to ct, and then we have the limits as 0 to n. So the next thing is just to substitute the values of t when it is 0 and when it is n. So we have the limit as n tends to infinity of, so when t is n, we have 1 over c e to c n, minus when it is 0, we just have 1 over c. So from here we were given the condition that c must not be equal to 0. So it means the value of c will affect the overall answer that we have there. So we're just going to consider the signs of c. So we consider when c is positive. So when c is positive, then the exponent will move to infinity, and we don't want that. But when c is negative, then the exponent will move to 0. So that is what we go with. So it means that the integral from 0 to infinity of e to ct with respect to t is going to be negative 1 over c, and that only happens when c is negative, meaning when c is less than 0. That is the condition that we have there.